name is Atika Basruddin. I'm going to talk about sorting. I'm going to talk about selection sort and heap sort for sorting algorithm. For the technique of selection sort, in my opinion, selection sort is the simplest sorting algorithm, which we can see in the example given. This is the simple example, which is we are going to sort the elements given an array of 6 integers. So we have index of from 0 to 5. So 1 should be the first minimum element, which is in index 3. So we sort the element element 1 from index 3 to the index 0. Now 2 deserve to be at position 1. So what we do is we swap with the element 2 and 7. We repeat the step until the list is sorted out, like this one. So now this is the sorted list. Then I'm going to the heap sort technique. In the heap sort technique, this given is the array of elements, which heap sorting only have 2 children with a parent and should start from the left. We will start the elements sorting it with the roots element of the first element, which is 8 in the index of 0. Then we create the node to the children, which is 4 and 7. And for the children of 4 and 7 is 1, 3, and 5. And for the insertion of heap sorting, let's say we want to insert 6 element of 6. So we should be insert into the under the to the children of 7. The difference between heap sort and selection sort is selection sort is a simple sorting algorithm that repeatedly search the smallest element and move it to the correct location, while heap sort is a comparison-based algorithm that uses a binary heap data structure to sort element. Second is for the selection sort, it will find the least element in the array and move it accordingly. And for the heap sort, the element are sorted in a special order such that a value in a parent node is greater, which is greater or smaller than the values in its 2 children, which is if the heap sort have the greater root, it's called a maximum heap. And for the smaller root, smaller element of the root, it's called minimum heap. Selection sort is simpler than heap sort and other sorting algorithm. It have very few steps to sort the elements, and compared to heap sort is more complex than the selection sort. Then we go to the algorithm efficiency of selection sort and heap sort. the algorithm must be judged by the worst case, average case, and best case, which is selection sort have better performance than other sorting algorithm, such as a quick sort, and it is not suitable to use for large data array, as when the data array increase, the timing will also increase. The heap sort is second best fit algorithm for sorting large data size after quick sort among other sorting algorithm. As you can see in the in this part, stable means if it does not change the order of the elements with the same value. For the application of selection sort and heap sorts, what I found is for the selection sort, they use the selection sort in social media monitoring tools. They use selection sort in social media monitoring tools to perform operations such as for data collection, cleaning data, saving data into database, searching for information, and reporting. And for the heap sort, it is used in what I found is in the research paper, the very old research paper I found. The ATM cell spacer. ATM stands for synchronized transfer mode that is used in transmission of network cell. The benefit of using heap sort is it gives unlimited waiting time. We can see it maybe for telco, it use this type of heap sort. Then for advanced data structure, I'm going to talk about B3 and Van MD Boss tree. For the B3 technique, given the example of tree of minimum degree T as tree and a sequence of integers, inserting an element on B3 consists of two, which is searching the appropriate node to insert the element and splitting the node if required. B3 insertion operation take place in the bottom-up approach. We can see if there is example given an array, which is firstly we have to search for the maximum keys in a node using the formula 2 times t equal to 1, which is 5, which is t. We insert 3 in t, we get a 5. Then we sort in 5 array. We sort in an array of 5 elements. When we then we are going to insert the 60. We have to take the middle key up and split it into children, which is 10, 20, and 40, 50. Then let's say I'm going to insert 70 and 80. So I just insert the element 70 and 80 from the right, which is it completes a 5 element in one array like this. Like we have like the maximum key is a node. Then last I'm going to insert 90 element of 90. In this array, we have to find the middle key, which is 60. We have to bring it upwards like this, and then only then we can insert the 90 on the right. For the 1MD boss technique, of 1MD boss tree technique, we just go briefly, as for me it's complex to understand. 1MD boss tree support search, successor, predecessor, insert, and delete operation in BO, log, and time, which is faster than any related data structure. When MD boss tree works with linear time complexity for minimum and maximum query. Given is 16 element, which we divide into clusters. So we get 4 clusters here, and this every cluster we have to search for the keys, which if there are maximum binary in a cluster, then it should be taken. It should be taken out. Wait. Okay. This is called summary, which is contains key present in the cluster array. Now, first we will look in the present cluster. If there is any key greater than query key, then we will be the successor. So we return it. If above is not the case, then we will call successor over summary to find the next true value in the summary. So there is no next true value, then we proceed to the next true value of the summary and find the minimum key present in the cluster, which will be the successor of the key. Difference between B3 and VEB Tree is B3 is a self-balancing data structure that maintains sorted data and allows search, sequential access, insertion, and deletion in logarithmic time. But for VEB Tree, a tree data structure which it implements an associative array with MB integer keys. Second is B3 is well suited for storage system that read and write relatively large blocks of data such as this, and VEB3 has a good space efficiency when it contains many elements, as it a very complex data structures. So for the efficiency, VEB, as we can see, in best, average, and worst case, V3 have BO log n, and VEB3 have BO log n, and B3 have linear space complexity, and this is stand for universe. VEB stores the keys in a bounded universe and perform operation in double logarithmic time complexity with respect to the universe size. Other than that, other than able to solve predecessor problem, VEB can also be used as implementation of priority queue. For the application, what I found in research paper of implementing B3 is file system of NTFS. B3 structures allows NTFS to group or index similar file names and then search only the group that contains the file, minimizing the number of disk access needed to find a particular file. especially for large folder. For VEB Tree, what I found in the research paper is used for interactive video on demand service in peer-to-peer network. It is used in P2P network to reduce latency jump, reduce server stress, and less cost for maintaining. That's all. Any question?
Okay, thank you, Atika. From me, for example, you are in a computer industry and you are assigned a task to write to sort the data that they have. So which sorting technique, which sorting algorithm would you use?
In computer science, again, madam, the station.
In a computer industry, if you are working in a if you are working, I'm not sure whether you are working right now. Masih tak kan?
No.
Belum kan? If you are working in a computer industry and you are your task is to sort the data that they have in that industry. What are the concerns in looking for the right algorithm?
Okay. For my opinion, I think I will not choose. I'm not sure, but I'm surely not choosing selection, although it's simplest and fastest, but for larger data, it is not efficient. And
then what will you choose then?
then maybe I would choose for this both selection or heap. I will choose maybe heap because it can I think it can support larger data, which is of course in the computer industry we have a lot of data inside.
So depending on the data, you mean depending on the data. And of course another concern is whether the data is online or offline. You know, that kind of if you are doing online online e-commerce kan, then you every time people enter another order, then you have to sort, isn't it?
Yes.
Straight away sort. As compared to offline, then offline you can take your time. It's okay to have less efficient algorithm.
Okay.
For B3, do you think that B3 has better searching time as compared to
Yes.
B?
Yes, I think B3 is have more efficient time because B3 have maybe is suitable for very large data because it's very complex to even it's very hard to understand. So I think B3 will be more efficient in time.
Due to what? What do you think? Because if I'm not mistaken, siapa tadi? I think Adam ke? There's a diagram showing that VEB kan? VEB you have a summary. So probably if you are searching for certain values, you can look at the summary, not going through the rest of the data yet. You just look at the summary. Probably you will find the data that you want. Then only you go through the apa dia panggil tu apa dia panggil cluster kan, then only kan VEB kan.
Yes.
So meaning even at the first level, if I'm not mistaken, okay, in my slide pun, the first level we have the number of values if it is not binary lah number of values that you can find in the rest of the VEB tree lah, the rest of the tree. If it is not within the range that you want to search for, then you don't have to search. You can stop searching. Ini summary punya level where you can check whether your data is the data that you want is in the list or not. As compared to B3, of course it is positioned in a proper order already. But B3 does not tell you right from the root node, does not tell you whether the number that you want is in the tree, somewhere in the tree or not. It's just that it cuts the searching time into half lah, less than half kan. So what I'm trying to say here is that of course VEB has its own benefits, dengan B3 pun ada benefits dia in terms of searching, and depending on how fast do you want to search the data, isn't it? So what do you think?
I think it's all different. It's all depends on the users and situation. Which I think advanced data structure can be focused on larger data or complex data. And for sorting algorithm, it may be it's not in range of large data.
Yes. Okay, and anyone else? Ke dah tak ada dah kat sini? Hazman must be around. Okay, anyone else wants to share?
No.
Okay.
Nothing from me.
Okay.
I'm okay. I'm good.
Okay.